Hello, welcome to Astronautics for Exploits. This is Dr. Ayanshola Ogundele. Water-powered spacecraft, future space exploration propulsion system innovative approach. The focus points are as follows. Water-powered spacecraft, advantages of water-powered spacecraft, working principle of water-powered spacecraft, and prospects of water-powered spacecraft. In the early 28th century, Robert Goddard, considered as the father of practical modern rocketry and spaceflight, was instrumental and credited with the development of several concepts such as rocketry, ballistic missiles, Earth orbiting satellites, and interplanetary exploration. Based on Goddard's inspiration derived from science fiction, he was one of the opinion that using rockets humans can undergo space travel. In 1914, after a series of hard work and iteration, Robert Goddard sought and received patents for multi-stage rockets and liquid-fuel rocket concepts that he developed. Afterward, in 1914, he stated his conviction about the possibility of a rocket having the capability to leave the Earth's atmosphere and reach the moon. On March 16, 1926, Robert Goddard launched the world's first liquid-propellant rocket. This is very significant in the field of rocketry. Over the years, after the launch of Goddard's liquid-propellant rocket, series of innovative ideas of launching rockets and spacecraft with less cost have been proposed. An example is using water as propellant. A water-powered spacecraft involves using water as propellant. This is achieved by splitting water into hydrogen and oxygen through the electrolysis process using electricity from the solar panels. Then hydrogen and oxygen are stored in separate tanks. Afterward, hydrogen and oxygen are recombined and then ignited in the rocket engine to create energy that propels the spacecraft and helps in its maneuvering in orbit. Water-powered spacecraft. Since the early stages of space exploration, which commenced in about 1950s, various space agencies and private space companies have been researching on how to use water for powering spacecraft. After decades of research and experimentation, the advent of low-cost CubeSats is making water-powered satellite to become a reality. Illustration of Pathfinder technology demonstrator 1 spacecraft, which demonstrated a water-based propulsion system in low Earth orbit, is shown in this picture. A water-powered spacecraft is a spacecraft that uses water as its primary propellant for propulsion. In a water-powered spacecraft, water is split into hydrogen and oxygen through electrolysis on board the spacecraft. Then the gases are burned to generate thrust, essentially acting as a green fuel source for maneuvering in space. A rendering of Vigoride, an in-space orbit transfer service for satellites, is shown in this picture. Advantages of water-powered spacecraft. Water-powered spacecraft have several advantages, such as clean and abundant resources, high specific impulse, safe and green compound, safer operations, fuel efficient, scalable, and long lifetime, environmentally friendly, and more cost-effective than the traditional chemical propulsion system. Water-based propulsion is more environmentally friendly than chemical propulsion because it doesn't release toxic chemicals into the environment. Lunar crater observation and sensing satellite is illustrated in this picture. Water is a safe green compound that can be used as propellant. It contains two combustible propellants once electrolyzed. Water is safer than chemical propellants, which are based on dangerous corrosive and toxic chemicals. Water-based propulsion systems avoid electromagnetic interference and risk of leakage. Equilos mission for measuring plasma distribution is shown in this picture. Fuel efficiency is another advantage of water-powered spacecraft. Water-based propulsion systems require less fuel to achieve the same amount of thrust as chemical propulsion systems. Water-based propulsion systems have fewer moving parts and require less maintenance. Another advantage is mass saving, scalable, and long lifetime. Water propulsion system can save mass on a spacecraft propulsion system and can be scaled for different satellite sizes. Water-powered engines can have a long lifetime in comparison to the traditional system. Illustration of Argo space plan to power update thugs with more water is shown in this picture. High propellant density is another advantage of water-powered spacecraft. Water is readily available and has a high density, making it efficient for storing large amounts of propellant. It is considered a clean fuel, producing only water vapor as exhaust. Illustration of Thales Alenia and Micron's water-powered propulsion system is shown in this picture. Working principle of water-powered spacecraft. A water-powered spacecraft operates using electrolysis principle, which involves splitting water into hydrogen and oxygen gases, and afterward stored and combusted together in a combustion chamber in order to generate thrust, leading to using water as a propellant by converting it into usable fuel through an electric current from solar panels. This process allows the spacecraft to maneuver in space using only water as its fuel source. Splitting process allows spacecraft to maneuver in space using only water as its fuel. The picture here illustrates Momentor's custom designed and built water plasma thrusters for its space tugs. Main processes of water-powered spacecraft involves electrolysis, solar power, gas storage, and combustion. Electrolysis is the core process of water-powered spacecraft, and in this process, an electric current is passed through water to separate it into hydrogen and oxygen gases. Momentum space tugs with the small sat-sized Vigoride is illustrated in this picture. Generally, electricity needed for electrolysis comes from solar panels on the spacecraft. The produced hydrogen and oxygen are stored separately in the pressurized tanks. When thrust is needed, the stored gases are mixed and ignited in the combustion chamber, producing hot gas that is expelled through a nozzle, thereby creating propulsion. Depiction of a momentous figured orbital transfer vehicle in Earth orbit is illustrated in this picture. Prospects of water-powered spacecraft. Water-powered spacecraft has the prospect of being used for deep space exploration, such as missions to Mars, the Moon, and asteroids. Water-powered spacecraft could be used for satellites that need to move between orbital altitudes. The CubeSat used in NASA's Pathfinder Technology Demonstrator 1 is illustrated in this picture. Presently, there has been various demonstrations of the feasibility of using water to power spacecraft, and according to findings, the teams of Ariane Group developed ingenious water-based propulsion system, and this system offers numerous advantages when compared with the electrical propulsion systems which are prevalent for satellite constellations. Illustration of Equus in moon orbit is shown in this picture. Water-based propulsion could revolutionize satellite propulsion system. Water-powered spacecraft could be used to explore the solar system, including the Moon and Mars. Illustration of Argo spaceships powered by water that will bring materials from Earth to the Moon and vice versa is illustrated in this picture. Water-powered propulsion could increase the mobility and capability of small spacecraft. Because water-based propulsion systems are reliable and could produce up to 14 times more thrust than electrical propulsion systems, water-powered spacecraft has high prospects. Illustration of Argo lunar water exploration concept is shown in this picture. NASA Pathfinder Technology Demonstrator Mission 1, launched on January 24, 2021, was designed to demonstrate hydrogen propulsion system with a water-based propellant that was developed through a public-private partnership with Theta Unlimited. PTD-1 propulsion system carried approximately 1 pint of water in a flexible bladder contained within a metal vessel aboard a campsite. The propulsion system separates water into hydrogen and oxygen propellants by applying an electric current through the water. Illustration of payload water thrusting used in Sony I satellite for water propellant demonstration is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Water Power Spacecraft, Future Space Exploration Propulsion System, Innovative Approach by Dr. Ayenshola Ogundele. With the focus points, water power spacecraft, advantages of water power spacecraft, working principle of water power spacecraft, and prospects of water power spacecraft. Thank you.